And now this one. So actually this is once again an ordinary problem, and okay, but there is a technicality here. So current is going from this way. Now it will be divided along this path, remaining will go here, then it will be divided here, remaining will go here, then it will come here, it will come here, it will come here, then it will go there, it will go there, it will go there. Well, um, I've used same type of values, so this question can be a predictable one. But okay, the logic which I want to explain you is, uh, if there is a division of wire, then this path of wire in which there is no resistance, this path of wire, it can be considered as single point, as if they would be divided in this way. It is a single point, we can consider that. Or if we just pull all these wire and join them on a single point like this, the situation will remain same. And similarly we can do this thing here also. So it is more onto this diagram. 2, 5, 3, similarly 2, 5, 3, R1, R2, R3, R4, R5, R6. So we can write R1, R2, R3 are in parallel. So 1 upon R is equal to 1 upon 2 plus 1 upon 5 plus 1 upon 3. So that is 30, 15 plus 6 plus 10. So R equal to 30 upon 31 ohm. And similarly, because they are identical, otherwise we would calculate them. Oh, I am putting subscript R1, 2, 3. Similarly, R4, 5, 6 is equal to 30 by 30, because it is identical, no need to show its calculation part. So R1, 2, 3 and R4, 5, 6 are in series. So R equal to R1, 2, 3 plus R4, 5, 6, and whatever be the proceedings. So, and in the same way, I'm leaving this problem for you. And I'm moving on to this one. Okay, so, but you have to do it. You have to do it. You can't simply jump to next. Okay, here E1, E2, E3, then E1, E4, E5, and then E6. So, in first branch, then second branch, then third branch. In first branch, E net equal to E1 plus E2 plus E3, 3 plus 3 plus 3, that is 9 volt. And net internal resistance 1 plus 1 plus 1, that is 3 ohm. Next, in second, E equal to E4 plus E5, that is 3 plus 3, 6 volt. And Rn, I should write 1, 2, 3 here, 4, 5 here, 1, 2, 3 here, 4, 5 here, 1 plus 1, that is 2 ohm. And here we have nothing to do, 3 volt, 1 ohm. And now entire this first branch acts as a cell which has EMF 9 volt, internal resistance 3 ohm. In the same way 6 and 2, in the same way 3 and 1. So now E1, 2, 3, E4, 5, E6 are in parallel. So first we will find their equivalent internal resistance, that is 2 plus 3 plus 6, 11 by 6, R equal to 6 by 11 ohm. And then that formula, En upon Rn equal to E1 upon R1 plus E2 upon R2 plus E3 upon R3. And that is, E1 is 9, R1 is 3, E2 is 6, 2, 3, 1. En upon 6 by 11. 3, 3, 3, 9. 9. So En is 54 by 11 volt. So these are some designer type of question. Few student call it Doraemon question. Okay, so cell is delivering along the diameter, so current will be divided this way and that way. So these two are in series, these two are in series, because there is single path, there is single path, but both are in parallel to each other. So I haven't mentioned here how much potential difference is there. I'm writing 10 volt, so you can solve it out, and you can do it yourself. That is a practice problem for you. So R1, R2, I'm doing it orally. So along this path, resistance is 8 ohm, here also 8 ohm, and both 8 ohm will be in parallel combination, so you can find it out, and then you can calculate current also. Anyway, now moving ahead, I have just modified the same problem here also. Here we have to find equivalent capacitance. Again, I haven't mentioned here what is the potential difference. Anyway, it's not that much required here. We are interested in capacitance, so I'm marking it as C1, C2, C3, C4, C5. Now see, if charge will go from here, it will charge this, then here it will be divided, then here. So both C2 and C3 are in series combination. So 1 upon C23 equal to 1 upon C2 plus 1 upon C3 equal to 1 upon 2 plus 1 upon 2, that is 1, and reciprocal of it is still 1 picofarad. And then this one, entire this one is in parallel with C4. C23 and C4 are in parallel. So C234 equal to C23 plus C4, 1 plus 1 equal to 2 picofarad. Now there is single capacitor. This one, that one, this one are in series. So C1, C2, 3, 4, C5 are in series. So C equal to C1 plus C2, 3, 4 plus C5 equal to 1 plus where is it? 2 actually. 2 plus 2 plus 2. 6 picofarad. And now I'm putting a question for you. If this cell is of 12 volt or battery of 12 volt, you have to find charge stored by each capacitor, which is going to be difficult. You can try it of your own. I'll make a separate video for that. Okay, moving ahead. This time, two cells are there. Are they in parallel combination? See, there is a single path. All right, there is a division of path, but for locally for these two, consider it as a single unit. So there is a single path. So both of these cell has to deliver current along this single path. So both will be considered as in series combination. E1 and E2 are in series. So E net equal to E1 plus, oh god, but opposite polarity. See, E1 is greater. For smooth operation or greater EMF, we have to connect this positive to negative of other cell, but it is connected to positive of this cell, so it will be E2 minus E1 minus E2 equal to 9 volt. And then it is quite easy that one more thing, I haven't mentioned internal resistances here. This type of problem can also be asked, that EMF is negligible, they can say. I just missed it out, so now I'm saying internal resistances are negligible. So R1, R2 are in series, so R12 equal to R1 plus R2, and sorry, they are in parallel. I don't know what I'm thinking. R12 equal to 1 upon R1 plus 1 upon R2, 1 upon 3 plus 1 upon 6. So R12 equal to 2 ohm. And R12 and R3 are in series. So R equal to R12 plus R3 equal to R12 is 2, R3 is 2.5. So it is 4.5 ohm. Now question can be asked to find current or potential difference, so you can do it. Okay, moving ahead here. Okay, so once again there are two cells, so their collective EMF will be measured. So E, and this time this positive is connected to negative, so it will be like this. All right, now what about these three? Actually, when we add up these EMF and it is now a single voltage source, so either we can place it here or there. So one place we will assign for this. So let us suppose we will assign place here. This is 6 volt and this is nothing now. So this is 6 volt, it is dividing charge here, and then so it will go like this. These two are in parallel and it is in series. You have to draw these circuit in the exam and you have to mark these points like as I'm doing, and see, no need to draw these arrows. In capacitor there is a charge distribution, no current flows. C1 C2 are in parallel, so C12 equal to C1 plus C2, that is 2 plus 2, that is 4 microfarad, and then C12 and C3 are in series. So 1 upon C is equal to 1 upon C12 plus 1 upon C3, 1 upon 2 plus 1 upon 4, and that is 2 plus 1, that is 3 by 4. So C equal to 4 by 3 microfarad. And once again, it is question for you, find potential difference across each capacitor. Okay, here again, so the way I am going to solve this, so also you can solve this problem. So I am going to solve this one, and in the same way, but keep in mind that series and parallel combination formulae are different in both, but the process will be the same. Okay, so here current is getting divided, then one of the part is going this way, other part is going that way. What does it mean? Actually these wires are not touching each other, so how are we going to do that? Remember, I told you that these elongated wire are not required. We can directly consider that it is connected here. So also this one is connected here, this one is connected here, and this one is connected here. Even we can unfold this wire. I mean, like this. One of the wire is going this way, other wire is going that way. I can do it like this, and I can do it like this. So I'm redrawing this circuit. Okay, nothing to do with this 15 ohm. Then it is going this way. What if I do it like this? Okay, so I've kept it here and moved this upward direction, so it became this, and I'm pulling this here. This is 5 ohm, this is 10 ohm now, this is 10 ohm, it is here 5 ohm now, and it is 15 ohm. All right, so we can mark it R1, R2, R3, R4, R5, R6. So we can write that R23 is in series. So R23 equal to R2 plus R3, that is 15 ohm, and R45 are also in series. R4, R5 are in series. So R45 is R4 plus R5, 10 plus 5, that is again 15. So R1, R23, R45 and R6 are in series. Are in parallel. So 1 upon R equal to 1 upon 15 plus 1 upon 15 plus 1 upon 15 plus 1 upon 15. Now you can do it. And okay, I'm telling you a shortcut that if two resistor or three resistor or more resistor of same resistance are in parallel, then there is a shortcut. You can save your time like this. If there are two resistors, I'm generalizing it RR in parallel combination, then their resistance will be R by 2, straightforward. If they are 3 R, then it will be R by 3. And whatever be the number of resistance, if they are equal, they are parallel, put the value of 1 divided by number of resistors. So same here, 15, 15, 15, 15. You can do it directly. R equal to 15 by 4 ohm. That's all. Okay, so you can do it here also. Remember, here the results would not be that much pleasant as here. Okay, so I'm moving ahead. Here we have to find current, and there are m branches. There is a direct formula also, but I will generalize this thing. So in first branch equal to Ne, and internal resistance in first branch will be Nr. And there are m numbers of rows, so E net will be equal to Ne. Nothing will be the effect on of these rows, because if you consider this entire as a single cell of EMF Ne, then in parallel EMF will be remain same because of same cells, but not with the internal resistance. Rn will be R net, actually net हो गया, net 1 upon Nr plus 1 upon Nr plus 1 upon Nr up to m terms. So in the denominator Nr will be there, and in the numerator 1 plus 1 plus 1 up to m is m. So R net is equal to Nr upon m. And now the current will be E upon R plus R. E is Ne, R is R net, actually E is E net, R is R net. Nr upon m plus m. No, sorry, what I'm writing, MNR. Ne upon m Nr m square Nr, and that's all. Not much simplification can be done. You can take n common, nothing more than this, m square R and n cancel, and that's all. That's all the answer. So there are some other circuit problems also. I will cover them in separate video, because this video has already gone too has become too long. So I'll cover these in next video.